Didn't see you there. My name's Stephanie, and I'm a graduate student at the University of Alberta, and I'm in the Land Reclamation International Graduate School. That was a lot of words. What is the Land Reclamation International Graduate School? It's a program at the University of Alberta that offers education and professional development for anyone interested in land reclamation. And by anyone, I mean undergraduates, graduate students, postdocs. It provides a bunch of different opportunities for us to learn about land reclamation. So what is land reclamation? So let's think about it. Our planet, as we know it every single day, is changing. There's no such thing as pristine nature anymore. When you think about all of the increasing human activities, we have natural resource exploration, agriculture. We see our human footprint growing every single day. Now let's add into that some natural disasters, forest fires, hurricanes. All of these together are damaging and degrading our Earth and our ecosystems. So what does that mean? Well, we're losing critical habitat types and we're decreasing our overall global biodiversity. So what do we do about it? Well, we've got two options. We can leave it or we can try to fix it. I'm a fixer, and the only way we can fix that is through land reclamation. So land reclamation is just taking this disturbed area and maybe turning it into something that was there before. So we can take a damaged thing and convert it back into something productive. Land reclamation becomes critical because 50% of the land on this earth has already been transformed by humans, while another 15 to 23% is set aside for agricultural or industrial uses. Every time we transform a part of the earth, we are contributing to the human-produced carbon dioxide emissions that are contributing to climate change. And these activities, as well as some others, are leading to massive global extinctions. I'm talking 100 to 1,000 times higher extinction rates than we've previously seen. So now, more than ever, we need to ensure that our environments are protected and that they're going to provide suitable habitat for all of our organisms. So globally, we know that there's issues and we need land reclamation. But what about closer to home? Let's scale it into Alberta. What kind of activities would require land reclamation? Well, Alberta's really unique. We're very energy rich, so we have unconventional and conventional oil and gas products, we have the oil sands, we have surface coal mining, we have pipelines, we also have transportation or logging, even urban developments. All of these will require reclamation at some point. And Alberta's extra unique because of our oil sands, because we're faced with certain challenges. Have you ever heard of tailings ponds? Those are actually really difficult to reclaim. So when we look at reclamation, there's multiple steps, and me, as a land reclamation scientist, or as I like to call Earth Doctor, there's multiple steps that I can be involved in and I can contribute to. So the first step with land reclamation is you're always going to want to identify what disturbance there is. So if there's mining, that means we're going to lose all of our vegetation and they're going to dig out some of the soil. But let's say we had a disaster or a disturbance like a forest fire. Well, the soil will be there, but we're going to lose our vegetation. So the first step is you need to figure out what kind of disturbance you have so that you know what you'll need to do for your reclamation plan. Second, you want to figure out what is going to be your end land use. So imagine I'm doing a reclamation project in Edmonton, maybe downtown brewery district, and I decide I'm going to turn it into a forest. That just doesn't make sense for an urban location. Same if I decided that in the northern boreal forest up by Fort McMurray, I'm going to put in a park. If it's in a remote location, that's not a good end land use. So we need to plan appropriately what we're going to put there. So once we know what our end goal is, the next step is remediation. What? Another R word? Trust me, there's lots. But remediation just means maybe there's some kind of contaminant, maybe there was a diesel spill, or maybe there was too much salt in your soil. There's a bunch of different ways you can take that contaminant and remove it so that you can move forward in your reclamation plan. The next step, again, depending on your disturbance, would be to place the soil. And this is where I excel, because let's be honest, soil is the foundation of life. You figure out how to put your soil back, how you're going to make it healthy, how you're going to have nutrients, and then your next step is to plan your vegetation. How are you going to get this ecosystem back? Are you planting trees? Are you planting shrubs? Are you planting berries? All of that goes into the planning, and there's tons of research that looks at what are some of the best vegetation properties to look for, how do we build a soil. Monitoring is the final step in the reclamation time plan, but it is the most critical. Right now in Alberta, we monitor things by picking an indicator. An indicator is that tells us how an ecosystem is doing. How is it recovering? Is it healthy? Is there any problems? Are things not growing? So the indicators we use right now in Alberta, we measure the soil and the vegetation properties. So the soil, we might look at what is the pH? Is there nutrients for the plants to grow? And when we look at vegetation, we look at what are the different species? Are there weeds? How many are there? How abundant is it? What's the health of these? And that's how we currently monitor it. But that is a very two-dimensional approach. It doesn't tell us anything about how an ecosystem functions. It doesn't tell us about food groups. It doesn't tell us about stability. It doesn't tell us about biodiversity. So I think we need to add a component to our monitoring. And what should it be? I think it should be soil invertebrates. And I've got a couple really good reasons why. First off, just like me, they're very sensitive. So what does that mean? They're sensitive to everything. If you apply fertilizer, if the pH of the soil changes too much, any type of management practices, when the vegetation changes, those little invertebrates will start to change as well. Okay, but we went too fast. What are invertebrates? Great question. They're anything without a spine. And no, I'm not talking about your ex-boyfriend. They're anything without a spine, like a worm, a mite, an insect, and they live above ground and below ground in the soil. They help with nutrient turnover. They'll take dead leaves and make them into nutrients for the plants. They help with ecosystem cycling. They help with stability and resiliency. Research has also shown that the presence or absence of specific groups of soil invertebrates can actually influence the overall ecosystem recovery timeline. So why are we not looking at them? Well, it's complicated, but they do need to be included in monitoring because they can alter an ecosystem's trajectory much earlier than if we only measure soil and vegetation. Okay, so I'm talking about soil invertebrates. Do you want to know some of my favorites? Great. So the first ones that I like to look at are mesostigmatid mites. They're predatory. They're big and they are very slow, but it's good because they take that predator notch in the food chain. The next step down, we have other things like prostigmatid or orobatid mites. So some of them can be a more fleshy body and they're not as armored, whereas orobatid mites, they're kind of like beetle mites. They're similar to earthworms in that they help give organic matter back into the soil, but they're heavily armored. They're little tanks and it takes them a really long time to move. Another one of my favorite inverts are the collembolans, or springtails. They come in a variety of colors. They can be just white or a vibrant purple, but the best part is they have an appendage called a furcula. It's a forked thing at the bottom, and they use it, they curl it up, and use it to projectile themselves, so their dispersal rates are very far. But really what we're looking for are things like pests, agricultural pests, or things that shouldn't be there. We're looking for the specific presence or absence of some of these groups because it will tell us about their dispersal as well as an ecosystem's health and recovery rate. So you know I'm doing research on invertebrates, and you know I'm doing research out at the Genesee coal mine. So how am I doing it? Well, here's a quick overview. I have some undisturbed forest areas as well as some disturbed areas that are actively undergoing reclamation. And every month from May to October, I head out there and I collect my invertebrates. So to collect the above ground invertebrates, so anything that decides to walk along the surface, I use a deli container that I put in the ground flush. And as they walk along, they fall into the deli container where there's a kill fluid and I collect them. That gives me the above ground. But my research is groundbreaking and I want to break literal ground. So in addition to collecting the inverts that walk along the surface, we take soil cores and we can extract them in the apparatuses that you see here. They're called a Tallgren funnel extraction. And all that means is I put my samples in while the bugs are still alive, I flip a light switch, and that creates a temperature and moisture gradient. So all of those inverts decide it is too hot and they start to move down, and again I collect them. So now I've collected all of the above ground and all of the below ground invertebrates. And then I can do exactly what I said I would, look at the presence or absence of some of these specific groups. All right, so we know I've collected millions of invertebrates, I've killed them all, so what does this mean? Well, hopefully it means karma isn't real, but also what we're going to use it for is to develop an early detection system. This detection system can be used by various stakeholders because I'm going to find out what invertebrate groups should be there, what shouldn't be there, and at what timeline they should appear. And this early detection system will allow them to find the problem areas, it'll allow them to implement early mitigation techniques, and it'll overall lead to more efficient and effective reclamation. Really what it's going to allow us to do is to have confidence. We're going to have confidence that the ecosystem that we have rebuilt that was damaged is now going to be on a successful trajectory. We will know that it will be resilient, we know that it will be stable, and we know that in the future, regardless of climate change or droughts or extended pests, that it will survive. And we need to know that with confidence, because now, more than ever, we need to take care of this planet, because there is no planet B. Okay, so now you've learned a little bit about land reclamation. I hope you understand the importance, and maybe you've fallen in love with those creepy crawlers just a little bit like I did. But do you want to learn more? That's great. The Land Reclamation International Graduate School has tons of outreach opportunities. We've actually just developed a Dungeons & Dragons style land reclamation game so that you can learn more about it. It works for adults, we can come to schools, post-corona. There's also the Future Energy Systems, which does outreach work. We do 3-minute theses, you can ask an expert, and we have people from all different types of discipline that would love to teach you and talk more about land reclamation. Thank you so much for watching and joining me as I share my passion about little invertebrates. They're small, but they're mighty.